Alright guys, we're going to go ahead and start reviewing for our Chapter 1 test. First off, when you look at the study guide review and you have this vocabulary, this would be the list of the vocab words that you need to know going into this test. Also, that'd be the list of vocab words you'd have to write down if you were looking for that extra assignment that I was giving you guys. But anyway, when you take the test, you are going to get a couple questions that talk about vocabulary. We're going to have like a matching section. So to go ahead and get started here, we'll start with actually, right off the bat with number 1. And you see how number 1 actually isn't 1-1, it's up here. Okay. So anyway, you just are matching the words. So you either know the words or you don't at this point. So anyway, number 1, it says a blank divides an angle into two congruent angles. So this is something actually I talked about when we're getting ready for that quiz, or we're starting for that quiz, but two congruent angles, well, that's going to be an angle bisector. Bisector cuts in half. Angle means it's cutting an angle in half. So we're going to have two congruent angles when that happens. So this would be angle bisector for number 1. All right, number 2. Blank are two angles whose measures have a sum of 90. That's a key on that. You got to know what adds up to 90, or what do we call angles that add up to 90, and that's going to be complementary angles. So that'll be number 2. Alright, next up, number 3. We have the length of the longest side of a right triangle. So when they're talking about the longest side, you're thinking that Pythagorean theorem. And it's going to be this side right here. That side is called, when you come down here, the hypotenuse. So number 3 is hypotenuse. Again, just a quick reminder, you're going to have a section like this on your test. There'll be a few more words in that, but you're going to have to match the definitions to the words. Okay, so that'll be 1 through 3. Try to keep everything on this page that we can. Alright, so next up, we got 1.1. So 1.1. Here we go. Number 4. Number 4, and again, you can always go through these examples that are already written out just to give you some extra practice. I'm just going to go through the problems that don't have answers to them. So number 4, we have 4 coplanar points. Name the following. So we need to find 4 points that lie on the same plane. So I'll look at this plane S right here, the orange one. I got 1, 2, so A, F, G, and E. All those 4 points lie on plane S. So I'll use that as a sample answer. So I got A, comma, F, comma, G, comma, and E. So again, these are 4 points. So I don't want to list them together. It looks like I'm naming the plane. I just want the points. So that's number 4. Number 5, again, there's more than one answer for that. So you could have gone C, G, D, B if you'd like, as well for plane R. All right, number 5. We want a line containing B and C. So if you look, here's line BC. It looks right in the middle there. You've got that point. If you can't see it right now, it's point G. So all you need to write for number 5 is G. You can write point G if you'd like. I'll just put G. We know what it means. Number 6, a plane that contains A, G, and E. So we're looking at A, G, and E. So all those points lie on that orange plane, so we need to name that plane. I guess the easy route would be to name that plane AGE, but I don't think that's what they're looking for here. So we're going to name it plane S. I think that's an S. It's really hard to see that. My S is the little script letter. I guess it would look something like that. Alright, so that's 4, 5, and 6 from 1.1. Again, you can always look at your notes for additional examples. Number 7, we're still in 1.1 actually, so I'm going ahead. Yeah, that's fine. So we're still in 1.1, so number 7, we want to write a line containing P and Q. We're looking at this figure. So draw and label each of the following. Okay, a line containing P and Q. So in this point, we want to, you're not looking at this figure, sorry. Okay, so we just get to draw our own. A line containing P and Q. So I'm going to draw P, Q, and we want a line containing it. So just draw a line that goes through those points. Simple. That's all you got to do. There's a line containing P and Q. By the way, not that they're asking for this, but that's how you would label it. PQ with the line on top, but this is the answer, just so you know. All right, number 8. We want a pair of opposite rays, both containing C. Okay, so we want you to draw and label it. So actually your answer is both of these, so that's the label, right? So we've got 2 answers. This one, I'm going to go ahead and just name them first, the names, and then we'll draw it. So a pair of opposite rays containing C, you would have something like this. AC going towards C, and then you want opposite rays, so I can just do CA. You can do an extra point if you want, but those are definitely opposite. They're going in different directions, and if I drew it, I'd have starting off A, C, and I'll go ahead and change color so you can see it a little bit better. Then I'm going to draw CA. It starts at C, and it goes towards A. You combine those, you're going to get a straight line. So that'll be number 8. So you got the label, and you got the actual figure. All right, number 9. CD, we want to label or draw line CD intersecting planes P and B. So this is the one where we have to draw the planes. You have to know that a plane extends forever, so your intersection will look like I would say a line segment, but you should know that it's not a line segment. So there's your 2 planes. There my planes intersect. So I'll draw the line in red here. Don't mind my line isn't straight. I do my best. Yeah, that's really bad. I'll try to fix that. It's not really looking perfect here because I didn't line it up as good as I could, but man, I can't draw. Okay. Alright. I'll try to fix that a little bit. So we got a line. If it's ugly this time, I'm just going to go with it. There. I just had to say it was going to be ugly. It's still ugly. Alright, so you got your line here, and that line should be somewhat straight. If you can't make it straight, then whatever. Okay. So your intersection is going to be a line. So you just need to know that. But you need to label these planes. So we got CD, line CD. So I'll label these points as C and D. You can kind of see it in there. It's hard to see, but it's there. And it's intersecting planes P and B. So I'll use another color for that. I got P, and I'll do this one as B. There's a B script. All right. So there's my 2 planes. There's the line. It's an ugly line. I get it. That intersects those 2 planes. Don't make fun of my ugly line. All right. Number 10. We are now in section 1-2. So 1.2. This one says find each length. So we're looking for JL. Oh, I should probably number that. So number 10. So we're going to look for JL. And what we do, again, to find a length, if we have the actual, if we're just doing on a number line, remember to find a length, what we do is we subtract the highest value from the smallest. It can go either way. If you subtract the smallest value from the largest, all you need to realize is that your answer is going to have to be an absolute value because distance is never negative. I prefer just to do the highest value minus the smallest. So I'm starting at J and I'm going to L. These are my 2 points, negative 1.5 and 2. So JL, the distance, would equal 2 minus negative 1.5, which, by the way, is 2 plus 1.5, which then equals 3.5. So number 10, 3.5. Okay, number 11, doing the same thing. We're finding HK now, though. So number 11, HK. You got to realize where K is. They don't have it labeled. Put a 1 there, because that's what it is, 0, 1, 2. So I'm going from negative 4 to 1. You might already know what that is. So HK is going to be 1 minus negative 4. Again, I always start with the largest value, go to the smallest. So that'll be 1 plus 4. Oops, I'm getting ahead of myself. The answer is 5. 1 plus 4. So HK equals 5. Alright, so that's number 11. Moving on here, number 12. So number 12, y is between x and z. So I'm going to go ahead and draw that segment. I got y is between x and z. I don't know where, so this picture isn't going to be to scale. So that's fine. They didn't say it's a midpoint, so notice I didn't put it in the middle. Alright, xy is 13.8. So that's 13.8. Xz is 21.4. It's almost to scale, not perfect. And then they want to find yz. Oops, did I say xz is 21.4 and I didn't label that? Pay attention there. That's my bad. Alright, so we want to do the entire, if I get that erased there. Now I'll get that dot, that'll be fine. Okay, so, sorry, they're giving me xz was 21.4. 21.4. There we go. Alright, they want yz. I can go ahead and call that something like x. So this is a situation where you'd be applying your segment addition postulate. I know these two pieces add up to the whole. So I would have 13.8 plus x, which is yz. You can write yz if you like instead of x, and that's going to equal 21.4. So I would go ahead and subtract 13.8 from both sides. And here we go. X equals, here I'm going to go ahead and borrow one of my units digits, bring it over here. So that's going to be 6. This one I'll borrow my units digit here, and that'll be a 10. So that's going to be 7. So I'm going to have 7.6 for x or yz. So remember that equals yz. So number 12 is 7.6 using segment addition postulate. Number 13, they're using algebra here. I'm going to force that algebra hand on you. So 13, we got Q is between P and R, and you have a picture that goes with this. So we need to find PR in this case. Okay, so in this case we're going to still use a segment addition postulate. They didn't say anything being equal. So 3x plus 6x plus 4. Those are your two segments added up, equals the whole segment, which is 14x minus 6. So now we're going to do some combining like terms. So just a quick summary on that. We got our x's here. I can combine those. So I'm going to have 9x plus, that is a 4, equals 14x minus 6. So do a little bit of math here. We're going to go ahead and get our x's together. Those will cancel. I'll go ahead then at the same time get my numbers together. So add 6 and add 6. And we end up with 10 equals, and that's going to be 5x. So if you divide by 5, x is 2. Now the question here is not saying what's x, it says find PR, but I got 2, so I can take that information and use it. So PR, remember, is 14x minus 6, so I'm going to write that out. PR is 14x minus 6, and I know what x is, so I'm going to go 14 times 2 minus 6. 28 minus 6 is going to be your PR, so that's going to be 22. 13, we get PR's 22. Both of these, again, just so you know, are using the segment addition postulate. Alright, so I'm on 13, so that next up is 14. I want to make sure we can still see it and I still have room to work. So again, I'm going to have to go ahead and kind of chop that up a little bit. I'm still in 1.2, but so you can see where I'm at. I'm down here in 14 now. I have to start saving some space. Okay, 14, now we're talking about midpoint. Now remember, midpoint means that you're taking a segment and breaking it into two congruent pieces. So in a situation like this, actually let me try to squeeze this up here so we have room later. I want to come up here, so I got my columns. Alright, so I'm going to try to squeeze this in. We can make this work. Okay, so 14. It's only got 2 problems, I can do this. Alright, so for 14 we have use the midpoint of TV. So if you want a picture to go with it just to get the segment, you can go ahead and do that. We have TV V, U, I'll put the little loop on the end so you know it's a U. TU is going to be 3x plus 4. And UV is 5x minus 2. Now, because they told you that this is going to be a midpoint, I know that these two segments are congruent. And what that means is that if I had to do an equation, I'd set them equal. So it's going to be 3x plus 4 equals 5x minus 2. So again, I'm setting those equal to each other then. So it's just algebra at this point. We're going to subtract 3x from both sides. So I'm going to also add 2 to both sides. So I'm going to get 6 equals 2x. And therefore, I'll come up here. I'm saving space as much as I can. I'm going to get x equals 3. Now the answer is not 3. It said find TU, UV, and TV. So only really have to plug this in one time. So TU, that's going to be 3x plus 4. So 3 times 3 plus 4, which equals 9 plus 4, which is 13. So TU is 13. Therefore, UV is 13 because they're congruent. Okay, they're the same length, so once you find one, you found both. Now TV is both of those combined, so if you add those two up, you're going to get TV, which is 26. So there's 14 using midpoint. So again, 12 and 13 used segment addition, 14 is using midpoint. Finally, we look at E. E is the midpoint of DF. So again, this is going to be tight, but we're going to make it work. All right, so 15, E is the midpoint of DF. So I'm going to have DF. E is the midpoint. Okay, and DE equals 9x. So I got 9x here. And EF equals 4x plus 10. So 4x plus 10. Now just like before, because they said midpoint, I know that this segment and this segment are congruent. So I'll use my little tick marks there. Alright, so just like before, I'm going to set these equal. 9x equals 4x plus 10. You can subtract 4x from both sides. I'm going to solve this for x. So 5x equals 10. Therefore, x equals 2. Okay, now if x is 2, we're going to do the same thing we did before. Find DE. DE is 9 times 2. Therefore, it's 18. So I found DE, plugging it back in. Now again, you can plug 2 back in here for EF. That'd be 4 times 2, which is 8, plus 10. But you can also know they're congruent and trust your math. If you don't trust your math, I'd plug it back in and check. But this is going to be 18 as well. And then DF would be that doubled. So that's going to be 36. Okay, so that's going to be section 1-2. Notice we did segment addition postulate. We did distance, segment addition postulate, and you can see it by column actually, and then midpoint to finish that up. Alright, so that brings us into 1-3. I'm going to start trying to save some space here. It looks like I'm running low on it. Okay, so we are now in 1.3. Here we go. Number 16. Alright, 16 asks us to classify each angle as acute, right, or obtuse. So I'm going to start naming these angles. So I got angle VYX. I'm going to go from left to right here. Okay, I got VYX. Now VYX, if you look, has this 90-degree angle. So that's going to be what we consider to be a right angle. Right means 90 degrees. So I'm going to say this is a right angle. Okay. Next up, I have XYZ. So angle XYZ. Those are arrows, by the way, that I'm drawing here. This is a really tiny one. It's 35 degrees. An angle less than 35 is going to be called acute. Remember a cute little angle? Like you're talking to a baby? Like that's a cute little angle. well, that's what we mean. All right. And again, there's a lot of angles in here, so I don't know how many they want us to really find, but there's a lot. So I got Z, Y, W. I want to go ahead and find them all. So we have angle Z, Y, W, another one that's less than 90. It's 55 degrees, so it's another acute angle. Now, if I decided to then go with my next angle, it would be a combination of other ones. I can go angle XYW, so I could do that. Well, angle XYW is going to be 90 degrees. We got 35 and 55, so that's going to be a right angle. And if I want to start making them big, I guess I can do that too. I have angle VYZ, and I'm not going to do all of them. You know, I guess I'll do two more. There's just a couple left after this. Once you get the idea, you get the idea. So this one would be greater than 90 because we got a 90 degree angle and a 35. So that'd be 125. So that's going to be called an obtuse angle. Actually, they only want you to go right, acute, right, or obtuse. Now, I could do VYW. That would be called a straight angle. But they're really not talking about that right now, so we're not really going to mention it. But, well, I mentioned it. But that would be a straight angle because it would form a straight line. But they're just saying right, acute, obtuse. So we'll just kind of leave it at that and go from there. Okay? Actually, I can go ahead and move this so at least it lines up with the other ones. Okay. So 17. I'm trying to save space here, but I'm not doing a good job of it. Oh, there's only 3 here, so let's go ahead and just work across. So 17. Alright, so number 17, what we have is we have a, looks like angle HJL. They're telling us this angle right here for this picture. That angle is 116 degrees, so they're telling me that this whole thing is 116. Okay, and they're not telling you these angles are congruent. If they did, you'd be able to label them congruent, set them equal to each other, and solve. But they're not saying that. So instead of using the angle bisector concept, we're going to instead use the angle addition postulate, which says if you add these two angles up, they equal the total. So this would be 13x plus 20 plus 10x plus 27 equals 116. You got to know what property to use. Unless they say bisect, like they do on 18, you can't set them equal. So if we combine like terms here, we're going to get 23x, and then 20 and 27 is 47, equals 116. I'm just going to go ahead and solve. Subtract 47. So I get 23x, and let's see, this becomes 16. Because I borrowed from the tens place. So 7 plus 16 is going to be 9. We've got to borrow again. 0, 1, and this is going to be 6. So I get 69. Next up, divide by 23. Divide by 23. Those cancel, and x is going to be 3. Now again, that's not your answer. You need to take that answer and go and plug it back into what we want. We want HJ K. So the measure of angle HJK is going to equal 13x, which is 3, plus 20. So that's going to be 39 plus 20, which in this case, I'll squeeze it in here, save some space, is going to give us 39, 49, 59 degrees. So we get 59 degrees for the measure of angle HJK. Alright, so again, angle addition postulate, add them up, solve for x, plug in. Alright, next up, 18. I'll try to move it up here, save as much space as I can. 18, now we're talking about a bisector. Okay, NP bisects MNQ. So I'm going to draw this angle. And there's no picture, we need to draw it. Okay, so now we got a bisector. And that's going to be called NP. So NP, and that bisects MNQ. So I have M, N, and Q. So here we go. MNP is going to be 6x minus 12. So 6x minus 12 degrees. And P and Q is 4x plus 8. Because these are bisectors, I can set those angles equal now. That's what bisector means, cuts into two congruent angles. So that means the measures are equal. So I can set them equal and go 6x minus 12 equals 4x plus 8. So I'm going to do a little bit of algebra now. Subtract 4x, subtract 4x. Okay, so I have my 2x on the left-hand side. I'm going to add 12 to both sides. So 2x equals 20. Divide by 2, just doing some algebra here. And x equals 10. Okay, so now I know that x is 10. Now what do they want? In this case, they want the measure of an angle, MNQ. So that's the entire thing. So what I'm going to do is I'm just going to find these smaller angles and double my answer. So if I do that, I'm going to have 6 times 10 minus 12. So 60 minus 12 is 48 degrees. Therefore, this should be the same. This would be 4 times 10 is 40 plus 8 is 48 degrees. So if I want to find the measure of angle MNQ, that's going to equal 48 plus 48, which is going to be 96 degrees. And that is section 1.3. Alright, now we're going to go on to 1.4. So here we go. Try it again. Save room. Scroll on down. Okay. 1.4. Number 19. Now we're talking about pairs of angles. 19, it says tell whether the angles are only adjacent and form a linear pair. Because remember, if they are forming a linear pair, just a quick reminder, I'll end up erasing this, but if you have a straight line and you have like these two angles, 1 and 2, a linear pair means that they have to be sharing an angle, because a linear pair means there are two angles that are adjacent that share a side that form a straight line. So these angles 1 and 2 are adjacent, they form a straight line, and they have to have both of those components to be a linear pair. So that's why it always says that it says adjacent and form a linear pair as an option. So if you just say linear pair, you are saying they're adjacent. So I'll just write linear pair if it's both. Okay. So 19, we've got angles 1 and 2. Now these, they do share a side. They're sharing this side right here. Okay, and remember, to share a side, they have to be next to each other, not within one another. So these aren't within one another. They are next to each other. They share that ray. So those are going to be adjacent, but they don't form a straight line. You kind of see the angle isn't a straight angle. So number 19 would be just adjacent. All right, number 20. 3 and 4, so we got 3 and 4, so we got these two angles right here. Now they do share a side, and you notice they lie on that line. So they're going to actually form a straight line, and they're adjacent. Therefore, number 20 would represent a linear pair. So 20 would be a linear pair, which means they're adjacent. And I said I'd say linear pair for this option because they have to be adjacent to be a linear pair. 21, we got 2 and 5. Now 2 and 5, notice they don't actually share a side. They got angle 1 in between them. So you got angle 5 here, angle 1 here, and then you got this guy sitting in the middle. So these are going to be not adjacent. So that's 21. Okay, so there's 20, or 19, 20, and 21. Okay, so now we'll look on number 22. Number 22 says find the measure of the complement and supplement of each angle. So here we have number 22 is the 74.6 degrees. So we're going to break this into two parts here. Start with the complement. Okay, so complement. Alright, so the complement, what we're trying to do is we're trying to say, okay, let's pretend this angle had another angle, call it like angle 1 or something like that, and they added up to 90. Well, if they added up to 90 and you want to find angle 1, you would have to go 90, which is the whole thing, and you are going to then subtract the 74.6 out. So you're going to go 90 minus 74.6. So to find the complement, you go 90 minus the angle. So in this case, that's going to be 15.4 degrees for the complement. Now we'd want to do the same thing for the supplement. You just have to look at it in another way. The supplement, you'd have to assume, okay, let's just say this formed a straight line, and there's angle 1. Well, now again, we got this 180 degree angle. Take away the 74.6. So if I'm going to do the supplement, so supplement, we're going to go now 180 minus 74.6. So really it's the same process each time. It's just one is you're subtracting 90, one you're subtracting 180. That's the only difference. In this case, that would be 105.4 degrees. So that's 22. Okay, so 23 is the same process. We're going to go complement, supplement. Again, the only difference here when we are now subtracting an expression. So you can't actually find the angle, but you can simplify and come up with the expression that represents a complement and supplement. So the complement here would be 90 minus your angle. Your angle just happens to be now 2x minus 4 degrees. So remember, in a situation like this, you're going to need to know to distribute that negative. You're subtracting the entire quantity. So that means I'm going to have 90 minus 2x plus 4. So that becomes 94 minus 2x degrees for the complement. Alright, so that'd be your complement. You do the same thing here with the supplement, except it's going to be 180, not supplements. I'll only find one angle here. I'll fix that. Supplement. Okay. So that's going to be now 180 minus 2x minus 4. Just like before, you distribute that negative. So you're going to get 180 minus 2x plus 4, or 184 minus 2x. Same difference, except now it's 184, not 94. So that's going to be your supplements and your complements. This is section 1.4. And with that, we're going to scroll on down to 1.5 using formulas. Alright, so 25. Let's go ahead and label that. We're in 1.5 now. Alright, so 25. We want to find the perimeter and the area. So remember, perimeter of a rectangle is 2L plus 2W. Area of a rectangle is length times width. So I'm just going to apply those formulas, starting with perimeter. Now again, you don't have to memorize a perimeter formula, because what you really need to know is that to do perimeter, you just add up all your sides. But this is a shortcut to it, because you're doubling L and you're doubling the width, because there's 2 of each and they're equal. So here I'd have 3x and 3x, but you can just write it as 2 times 3x. I'll use that as my length. It doesn't really matter, honestly. My width, I'll go 2 times 4x minus 1. And again, your perimeter, you're just adding all those sides up. So as you keep working this out, this would be 6x. Distribute the 2, and you're going to have 8x minus 2 for the perimeter. Simplify that down a little bit more, and you're going to get 14x minus 2. And if you're going to use units, it'd just be a U to represent units. We don't know what the units are. It could be feet, inches, miles, whatever. But it would be just units if you wrote it. It wouldn't be feet squared or meters squared, or like I said, units squared. All right, so that's going to be your perimeter. For the area, it's length times width. So I'm going to go 3x times 4x minus 1 for my area. Same thing, we distribute. That's going to give me 12x squared, and then 3x times negative 1 is minus 3x. Just like before, we can't do much with that. We just write an expression. And here on this one, I'll just put a parentheses so you know it's that units. That way I'll do the same thing here. It's 12x squared minus 3x units squared now, because now we're doing area. And that's your area. Okay, so that's area and perimeter of a rectangle. I'm going to go ahead and do the same thing. I'm going to save a little bit of space here. I'll move this formula up so we can work next to this problem. Okay, 26. Actually, let's move this up a little bit. Give myself some space. We know the formulas. Actually, this is a square, so I'll write the formula for this one as well. So for 26, just remember area of a square. In this case, it's length times width, but your length and the width are the same, so you can call it like an S for side length squared. Again, the lengths are the same, so you multiply the length and the width by each other, but they're the same number, so it's the same as squaring it. And now we have the perimeter of the square, and because again all the sides are the same, you don't have to go 2L plus 2W. You can just go 4 times whatever the side length is. So that speeds things up a little bit. So let's go ahead and find our perimeter. So the perimeter in this case is going to be 4 times, in this case our side length is x plus 4. Okay, so we're just going to go ahead for 4 and do 4s. We distribute in this situation, so it's going to be 4x plus 16, and you're done. Just make sure you write units. We don't know what the units are, but they're units. Alright, next up we have our area. And to find the area, we're going to go s squared, which means we're going to multiply the term by itself. So it's going to be x plus 4 squared. This is a good little review from algebra, because a lot of people, what they'll do as a mistake on something like this is they'll just distribute that square, and you can't do that. You got to understand what squaring means. Squaring means you're multiplying something by itself. So this is going to be x plus 4 times x plus 4. You actually have to FOIL this. If you don't FOIL it, well, you're going to be wrong, because you're not multiplying the term by itself. You can't call it x squared plus 16. Sorry. If you actually FOIL it out the way you're supposed to, you're going to get x squared, and then plus 4x for the outside terms, and then 4x for the inside terms, plus 16 for the last terms. And that leaves you with x squared plus 8x plus 16 for your area, not x squared plus 16. And see, if you don't FOIL it, that 8x isn't going to be there, and well, that's going to be a problem. So this is going to be units squared, because we just did area. So that's 26. Alright, so again, looking at 26, we did the perimeter area of a square now. 27. 27, we're doing perimeter and area for a triangle, so you just got to know the formulas for this. So you got your area of a triangle. That's going to be, again, just a review, 1/2 base times height. And your perimeter is really just, again, all the sides added up. There's going to be 3 sides here, so we'll just call them A, B, and C. So again, we'll start with the area. That's pretty easy. You just have to know how to add and combine like terms. So for perimeter 27, we're just going to add our 3 sides up. We got x minus 5 for our first side, plus 8 for our second side, plus 12. So we're just adding all 3 of these up. So you can go ahead and combine like terms as you're doing this. So I have a minus 5. Again, just notice here, I know the parentheses. However, you can, as you can see, there's nothing really to do inside those parentheses, so you don't really need them in this case. And then I have plus 8 and plus 12. So I'm going to combine those 3 constants, and my simplification here is going to be negative 5 plus 8. That's going to be 3. 3 plus 12 is going to be x plus 15. And again, remember we're doing units on this, so parentheses units, because we're doing a perimeter. All right, next up we have area. I'm going to do area formula, 1/2 base times height. So area is going to be 1/2. Make sure you understand what the base is and what the height is. It's 12. That's hypotenuse. It is not your height. So you're going to have your base, which is x minus 5, and your height has to form a right angle with that base, so that height's going to be 8. So we're going to be going 1/2 times the base, which is x minus 5, times the height, which is 8. Now, when you multiply, just so, again, quick example, like if you're going 2 times 3, you understand that's the same as 3 times 2. It doesn't really matter what order you're doing it in, and I say that because, oops, I need to go back. I'm on the wrong thing. There we go. I say that because we have two numbers here that I would probably want to multiply first. That'd be my 1/2 and my 8. You probably want to do that first instead of distributing that 1/2 inside the x minus 5. Otherwise, you're going to create two new fractions. However, if you multiply the 1/2 and the 8, you get a much simpler expression, which is just 4 times a quantity 2, or not 2x, 4 times a quantity x minus 5. Again, a lot easier than dealing with the creating extra fractions here. Alright, so I'm going to, in this case, I'll just distribute my 4 instead, and I'm going to get 4x minus 20 for the expression for my area. Remember, this is area, so we're going to go units squared. Alright, so that's 27. So we did area of a rectangle, area of a square, area of a triangle. So by the time you get to 28, it should be a little more self-explanatory. I don't need to write the formula again, so I'm just going to go ahead and solve this real quick. 28, we got our perimeter, is 2L plus 2W. So that's going to be 2L, which is 40 for the 20 here. I went 2 times 20. Then I'm going to go plus 2 times 5x plus 7. So again, just go ahead and add these up, combine like terms. It's going to be 40 plus 10x plus 14 if you distribute the 2, which is 10x plus 54. Again, doing with perimeter, it's going to be units. We'll do this a little faster here, so we've already done a rectangle. 29, we have, oops, I'm sorry, I gotta do area. Okay, so for area, we're going length times width. So it's going to be 20 times, in this case, your width is 5x plus 7. And you got your parentheses. So distribute that 20. 20 times 5 is 100, so we're going to have 100x. And then 20 times 7, well, if you know 20 times 5 is 100, we have 2 more left over, right? So we're going to have 40 more, so that's going to be plus 140. A little bit of mental math as you go through that. In this case, again, we're done. We just simplify it as much as we can. We can't really simplify anymore, so it's going to be units squared. It's our area, and there you go. Alright, so that's, again, rectangles, squares, triangles. You've seen these all before. It shouldn't be anything new to you. And now we're going to go into circles. Again, I guess before I start this, I just want to do a quick reminder. Again, you have the area of a circle is pi r squared. You got your circumference of a circle is 2 pi r, or you can think of it as pi times d. Okay, so easy way to kind of get these straight. When you're doing area, your answer when you're done is going to be something units squared. Think of the squares in the area formula as a reminder that you're doing area. And I say this because students typically skip these backwards. They'll do circumference when they're supposed to do area or vice versa. So remember, square matches the square in the answer. If you're doing circumference, there's no square in this. Well, it's because when you do your units, you also have no square. It's just units, not units squared. So it's, again, an easy way for you to remember when you're dealing with area and when you're dealing with circumference, which is the same thing as perimeter. So in 29, scroll this down a little bit. Alright, so in 29 we have, we're going to have to use a calculator on this. You kind of see what they're having you do. Find the circumference and area to the nearest tenth. So we'll use a calculator as we work these out, and that's fine. If not, we can use 22/7. I may do that on one of them just to remind you in case you're not allowed to use the calculator on your test. All right, so circumference, let's start there. Circumference is going to be 2 pi r. The radius in this case is 21. They're giving you the radius, so you're just plugging it in. So we're going to have 2 times pi times 21. Now because in this case we're going to be rounding the nearest tenth, we're going to need to use your calculator on that, because you don't know what pi is. You know an approximation of it, but you don't know the actual value. So we're going to go 2 times pi. Now I'm doing it on my calculator, you can do it on yours. And that's going to be times 21. And you should get, in this case, approximately. And I like to remind you that if it's not actually the number we're getting, we are rounding it off. So what you should actually be saying is approximately. So you do the little squiggly lines there for the equal sign. And it's going to be rounded to the nearest tenth. So the answer is actually 131.94. But the tenths place is the first spot to the right of the decimal. So we see the 9.4, we round it down to just 9. So it'll be 131.9. In this case, we actually have units, so we're going to use it, meters. So there's your circumference, approximately 131.9. If I did area, it's going to be pi r squared. So this one, just to remind you, because we can do squares and things on the calculator, let's do this without a calculator. It'll be a little big, but we can handle it. So what I'll mean by that, I'm going to go 22/7 for my pi. And I know they said round the nearest tenth. We'll end up using a calculator to get that answer. But r squared is going to be 21 squared. So again, I know that's kind of big, but you also got to remember to use order of operations. So as much as you want to just cancel the 21 and the 7, you can't, because PEMDAS, exponents come first. You got to multiply that out first. So quick little shortcut to this, you could go 22/7, and this is 21 times 21. That's what 21 squared is, and you can look at it like that. You probably weren't going to look at it like that, but you know, now you can. Understand that you're just multiplying that number by itself. So if you do it this way, you can then just cancel one of your 7s with one of the 21s. That'll be a 3. So 3, 21 divided by 7 is 3. And now we won't have any fractions. It'll be kind of nice. So you can see you don't have to really round this. You just multiply these 3 numbers together. Okay, so I know we can probably multiply these out pretty quick, hopefully. But 21, we actually do that. Let's go 22 times 3. That'd be 66 times 21. So you can multiply it out that way. So 1 times 6 is 6. 1 times 6 is 6. Move over to your tens place when you're multiplying by the 2, because it's 20 that you're multiplying by. 2 times 6 is 12. And we have 2 times 6 is 12 plus 1 is 3. So add those up. I got 6, I got 8, I got 3, I got 1. So your area is 1,386 meters squared. I don't need to get the decimal equivalent because, well, there is no decimal. So I can actually say equals on this. I don't even need to say approximately. Well, actually I do. You think about it, I did round off my pi, didn't I? Okay, so let's go ahead and get the decimal answer on this. If I was going to do the decimal answer again, we wouldn't be using 22/7, right? Because 22/7 is an approximation of pi, it does not equal to pi. Therefore, if I was going to do decimal equivalent, I do want to give you that answer so you can see it. You would just plug it into your calculator as 21 times 21, or you have a square button, you can do that. So that's 441, and we're going to multiply that by pi, and we're going to get 1385. You'll see your answer is pretty close because we did an approximation of pi. So it'll be 1385, and we're rounding the nearest tenth, so it's 0.44, which means I round down. So 0.4 meters squared. And then on that one I need to put the approximation symbol because that's not the actual answer, but it is actually closer than what I had up above. But at least with what I had up above, I knew that that was the actual answer I was getting from what I was trying to solve with. So There we go. I guess you could have an argument where you can say, hey, since I rounded off pi, shouldn't I say approximate here for my area? And you probably have a point, so I can do that as well. Okay, so that's 29. Now 30, as you look up here, I got to scroll back up so you can see it. On number 30, we have what we are given, in this case, is a diameter. So our diameter is 14 feet. So you need to make sure, especially for area, you get the radius, which is 7 feet. So in this case, we are going to find circumference, and I'll just use it on the calculator this time, but we're going to do circumference and area, but we're going to have to make sure that when we do circumference, we go pi times d. So pi times 14, we don't need to do 2 pi r. And for area, we'll have to use our radius. So make sure you pay attention to which one you're using. Alright, so in this case, we're just going to go 14 times pi. So 14 pi is 43.98. So I'll write that out before we round it so you understand how to round this correctly. So that's 43.98. Now we round to the nearest tenth. So this 8 would tell me to round that up, that 9 to a 0. But that 0 is actually not a 0, it's a 1. So that means we actually pull that 1 up here next to our 1's digit. So this answer would be approximately 44 feet for our circumference. So you just have to keep moving that decimal place over. Okay, so that'd be 44.0 basically. Alright, so that's 30 for the circumference. I was going to do the area. Remember, pay attention that we need to be working with our radius here. So it's going to be pi times 7 squared. So in this case, we're going to get 49 pi. 49 pi, plug that in your calculator. 49 times pi gives you an approximation here. If my calculator doesn't screw up, I want to go pi times 49. Do it the other way. And I'm getting 153.93 in this case. So this is going to be approximately 153.93. Is just going to stick with my 9. And this is going to be feet squared because I was doing area. Alright, so there's 30. Area, circumference. Alright, 31. 31, I am now going to be just kind of doing, let's see what we got here. We got an area of a triangle. Okay, so they give me the area of a triangle. So first off, before I even really get into this problem, remember area of a triangle is 1/2 base times height. They're giving me the area, so I'll just plug that in now. I got 102. That's my area. The base of the triangle is 17, so let's plug this into the formula. I got 1/2 times 17. Now I need to find the height. So you can kind of see what they did there. They're giving you the answer. We got to kind of back solve it to get the value that would give us that answer. So if you're looking, we have again 1/2 times 17. I can't actually divide those. What I can do though is I can move them over one at a time. So I'm going to do that. I'm going to start by multiplying by 2 over 1. I'll do that on both sides. I'm solving this for h. So that's going to give me now 204 equals 17h. Next up, I'm going to divide by 17. So again, that cancels with your 17. And to figure out how many times 17 goes in 204, we got to do a little bit of long division. So here we go. Alright, 17 goes into 204. Now 17 does not go into 2, so we're going to move over to the tens place. 17 does, however, go into 20 one time. So we see what's left over when I do that. And you go 20 minus 17, that gives you 3. Pull down your 4. So now I'm asking myself, 17 goes into 34. How many times? Well, that's going to be 2 times. So your height is 12, right on the dot. In this case, we have 12 meters. Make sure you label that. It is a height, it's not an area, so it's meters squared, so linear distance. Okay, so 31. So that is going to be 1.6. So again, we're just looking here. We have, sorry, it's 1.5. My bad. So now we just have 1617, getting towards the end here. So let's go ahead and wrap this up real quick. Okay, so we are on 1-6, number 32. So 1-6 are dealing with midpoint and distance, or when I say distance, you have Pythagorean theorem. So 32, Sarah, they're telling you y is the midpoint of AB, so find the missing coordinate. So this is going to be, and I'll put the formulas up here. You got your midpoint formula is the average of the x's, so x1 plus x2 over 2, average of the y's, y1 plus y2 over 2. So we're going to be applying that formula here to find midpoint. So in this case, we're going to add my x's up. So the midpoint is going to equal 3 plus negative 1 over 2. And add your y's up. We're going to have 2 plus 4 over 2. So simplify and you're done. We got 2 over 2. We have 4 plus 2 is 6 over 2. And your midpoint is going to be 1, 3. These can go pretty quick if you know what you're doing. Alright, so now we're going to move on to number 33. You'll see I already actually labeled this up here. So in 33 we have A and B. B is the one we're missing though. Now if you look, this is segment AB. So B is actually an endpoint now, and they're giving us the actual midpoint. So this is going to be similar to the one problem that we did just a minute ago with the area of a triangle, where we were given the area. We actually had to back solve and go back and find H. Well, that's what we're kind of doing here. They're giving us the midpoint, and we need to back solve to get B, our endpoint. So I'm going to go ahead and do that with number 33. So I'm going to start it up a little higher here. So I have, in this case, my answer, which should be -2, 3. Well, that equals, using my midpoint formula, the sum of my x's, which is 5 plus x over 2, and the sum of my y's, which in this case would be 0 plus y over 2. Okay, so if you're solving this, you know that -2 is the answer. Well, how do you get it? Well, you get it from that, from 5 plus x over 2. So we need to then set those equal to each other. So we're going to go -2 equals 5 plus x over 2. And if we're going to solve this, you would multiply both sides by 2. So I get -4 equals 5 plus x, and then subtract 5. So x equals -9. Okay, so there's your x value for B. Next up we have 3. That's our y value here. That should be the answer when we do 0 plus y over 2. So in this case, I'll do the same thing as before. I'm going to set now 3 though, the y value equal to 0 plus y, or I'll just write y over 2. In this case, it's a pretty quick one to solve. We multiply both sides by 2. Those cancel, and I end up with y equals 6. So your answer for the endpoint, remember we found the x and y, is going to be -9 for x and 6 for y. Now the one thing I'm not doing, just so you know, that I did in class, if you aren't 100% certain with your answer, remember we can draw a picture. You can draw a coordinate plane, and you can actually label these points. I actually said you should probably do that. Because of space and time in this situation, I'm focusing on the algebra portion. But remember what we did in the notes. Remember what I went over in class. If you draw a picture to go along with this, you can see if this answer actually makes sense or not. That way, if you screwed up your algebra, you can tell, because your graph will not match your answer. So that's, again, a helpful reminder. You want to make sure you remember that when you go through these. Next up, I'm going to, let's see, I got 34. I'm going to try to squeeze it in here. I'll move it way up to the top. Okay, 34, same scenario. We're finding A now. It's the same difference, though, because it's an endpoint. So remember, we have the answer. We have the midpoint, -2, 3. And it equals, you got your x values, x plus -4 divided by 2. And I have my y values, which are going to be y plus 4 over 2. It's a little small there, but hopefully you could see that. So you set the x values equal. Okay, I know the answer and I know how to get there. So this is going to be negative 2 equals x minus 9 over 2. And I'm going to have positive 3 equals y. Am I saying that? See, I can't even read my own writing. That's going to be y minus x minus 4. So I have negative 2 equals x minus 4 over 2. And I have 3 equals y plus 4 over 2. Okay, so as you saw both of these, the first step would be to multiply both sides by 2. So that's going to give you negative 4 equals x minus 4. Same thing over here. I multiply both sides by 2. I would get 6 equals y plus 4. Finally, to solve this, we just add 4 to both sides. We're doing that inverse operation. And I'm going to get 0 equals x for one side, or for one value, for my x value. For the y value, subtract 4 from both sides, and you're going to get 2 equals y. So in this case, this is now point A. Point A is 0, 2. Alright, so that is 32, 33, 34. Those are all dealing with midpoint. Again, there's only 2 scenarios you're going to have. Either I'm going to ask you for the midpoint or ask for an endpoint. So there's 2 examples of the harder version here of finding endpoints. Okay. Next up, I'm going to use a distance formula. Now remember, I'm not a huge fan of the distance formula because I prefer Pythagorean theorem. So I'm actually going to draw the pictures on this. So for 35, you're going to see a picture that goes along with this. So I have negative 2, 4, and 6, 1. So I'm going to go negative 2. Actually, I'm going to go out 6 on both directions here. 1, 2, 3, 4, 5, 6. And I'm going right 6. I only go up 4. So that's all I need to go up. 2, 3, 4. And 1, 2, 3, 4. Okay. So we'll just go ahead and label this. And I'm going to do xy. So negative 2, 4. So negative 2, 4 is right here. You can actually write it. Negative 2, 4. And 6, 1. So 6, 1. And we're going to find the distance between those 2 points. So in order to do that, we need to set up a right triangle. So to set the right triangle up, you can do it any way you want. I'm going to come down here to 1 and work my way over to 6. So I have my right triangle set up. That way I can use Pythagorean theorem, because remember, Pythagorean theorem is the distance formula. So doing my vertical, my height, distance, I'm going from 4 to 1, or you can say I'm going from 1 to 4, so that distance is going to be 3. Remember, you just subtract 4 minus 1 to get distance. Highest value minus the smallest. Get the horizontal distance, you can count negative 2 to 6, or go 6 minus negative 2, which we did earlier, and that's going to be 8. That is an 8, by the way. There we go. And I'm going to find C, my hypotenuse. So in this case, we are just going to go a squared plus b squared equals c squared. So 3 squared plus 8 squared equals c squared. 3 squared is going to be 9. 8 squared is 64. That equals c squared. Therefore, c squared equals 73, which is not a pretty number. Well, that's fine. Now again, you see, do they want the answer written as a decimal? In this case, they do. It says find the distance to the nearest tenth. I will show you again, it is a radical. You could square root both sides here. You're going to get the square root of 73. You have to do that either way. And then we can find the decimal equivalent of that answer just by square rooting it real quick. So the square root, let's see, of 73, that's going to be 8.54. So we're going to round that to the nearest tenth. Therefore, C is approximately 8.5. By the way, that equals, not equals, that is what we say is an equivalent distance of, in this case, xy. So if you want to write it the correct way, it would look like that. Remember, there's no segment on top. That would mean the shape, xy, the figure. Alright, so that's 35 using Pythagorean theorem. Just to show you different ways, on 36 I'm going to use the distance formula. So 36, we have 0, 3, and negative 2, 4. So 0, 3, negative 2, 4. So I'm going to call this x1, y1, and I'll call this x2, y2. I'm going to use the distance formula. So distance equals the square root. Okay, now we're using the distance formula. It's going to be x2 minus x1 to get started. So negative 2 minus 0 squared, subtracting your x's, plus y2 minus y1, which is 4 minus 3 squared. And you just plug into the formula and solve. So this will be negative 2 squared plus 1 squared, which is the square root of 4 plus 1, or the square root of 5. So your distance in this case is the square root of 5. So square root of 5, simplify that. 5 square root is 2.23, round to the nearest tenth, so that's approximately 2.2, which in this case we are trying to find what? HK, so you can call that HK. So 36, you write your radical 5, 2.2, whatever one you want to use for it. 37, just because I've used mostly Pythagorean theorem, I'm going to do one more distance formula just so you see it. So in 37 we have negative 4, 2, and we have 3, negative 2. So I'm going to do distance formula one more time. I'm going to call this x1, y1, and x2, y2. So here we go. Distance equals the square root. Scroll down a little bit here. Okay, so I'm going to find the square root by doing x2, or find the distance by doing x2 minus x1. So that's going to be 3 minus negative 4, quantity squared, plus y2 minus y1. So I did 3 minus negative 4. Now I'm going to do negative 2 minus 2 squared. So this ends up simplifying out as 3 plus 4, so 7 squared. Negative 2 minus 2 is plus negative 4 squared. Alright, so keep simplifying here. Again, all we're doing is Pythagorean theorem. But I have 7 squared is going to be 49. Negative 4 squared is 16. Okay, so that's going to be 49 plus 16. So that's what, 59, 65. 65 is another one of those things. It's not a perfect square, so we have to get a decimal equivalent. It's right over 8. But 65 square rooted is about 8.06, round to the nearest tenth. We're going to approximately 8.1 here, which is our distance, which using the points that we're given is going to be LM, the distance from L to M. So we'll call that approximately L, the length LM. And that is 1.6. So we're almost done. We have, what, 3 more to do? So that won't be so bad. So here we go. Let's wrap it up real fast. Alright, we are currently on, I got an extra space here. Okay, we're good. I'm currently on 1.7 now. Oops. 1.7. Okay. So here we go. 38. This is all going to be on your translations. You got your, or transformations. You got your translations, your rotations, and your reflections. So in this case, we want to identify each transformation, use arrow notation to describe it. So here, if I'm going to describe this, I have E. If you look, it looks like it kind of went over here, but it's not lined up perfectly. So it's been moved, yes, but it's also been rotated. So I'm rotating each one of these points. Okay, so as you rotate that one, it moves up. So this is going to be a rotation. So as you're looking at these answers, or I mean, if you're looking at what type of transformation this is, 38 is going to be a rotation. Now this one you have to kind of draw a picture to go along with it. I'm just going to use the picture they already gave us. So what you have is you want to pick a point and that it's rotating from. So you can call like a point P. Okay, so here we got point D, and it's been moved over to D prime. Okay, so you got your describing that transformation. You say it's rotating about point D. Now 39, we have point P, and we can just say this one is going to be sliding over. I can kind of draw a picture of that. That's an ugly picture, but you get the idea. Okay, so it's like I'm taking this and I'm just sliding it over here. Okay, so that's going to be, in this case, a translation. So 39 is a translation. So in this case, we again are just moving this from here to there. Okay, so just draw the arrow to kind of describe that. Alright, and finally we have number 40. They're giving us coordinates, and we want to find the coordinates for the image. Now remember, when we do a translation, we're going to have A, B, C, or those points that represent our figure. Say it was like a triangle. You don't know this yet, but it'd be a triangle if I did that. If I translate it, this is our pre-image. Our final value would be A prime, B prime, C prime. That would be our image. So just using that as a quick reminder here, because here we got our coordinates for, well, actually here, triangle XYZ, and they're going to be translated right 4 and up 5. So we need to make sure we can label that correctly. So we want to find the coordinates of the image if it's been moved. So we have point X, it's -5, -4, and what I'm going to do is I'm going to move that point right 4 and up 5. So it's going to look just like the translation rule. So if I want to find X prime, here's what we're going to do. X prime is going to be -5 plus 4, because that's what we're doing with our X values, and Y is going to be -4 plus 5. So there's X prime, which, by the way, is -1 and then a +1. So there's X prime. Next up, we have Y. We're going to do the same thing. We'll just keep repeating the process. We have -3, -1. Let's translate it. Y prime. That's going to be -3 plus 4, and then -1. Well, we're going to go plus 5. Do our same translations. So Y prime is 1, 4. So I got X prime, I got Y prime. Finally, I got Z, which is -2, -2. So we're going to do our translation for Z to wrap this up, and I'm going to have -2 plus 4 and -2 plus 5. So Z prime would be 2, 3. So you got your coordinates of your triangle, and really that's all they're asking for. Find the coordinates for the image of that translation. So you got your 3 coordinates: X prime, Y prime, Z prime. Alright, so that is your test review. So you can't complain that it's too much work, because I did it. So if I did it, you can do it, right? Hopefully you kind of go through this, use this as a good study guide, take advantage of all this work. Alright, and good luck next week, guys.